Hi friends, this is Temu. Welcome to my channel, The Cloud Security Guy. In case you are new here, I talk on a weekly basis about things like cloud security, artificial intelligence, and general cybersecurity career advice. So today is a bit of a special video, which is based on a lot of feedback, and it's a continuation of the previous video, which is basically the CCSP crash course. So as I mentioned before, we are covering all the domains of the CCSP, and this is a crash course I've made covering all the concepts which are there in the CCSP, and this has been made to help you out and to help you out with passing the CCSP. Today we're going to be covering domain 2. Domain 1 I've already done, and I'll link it here in case you want to go and watch it. And just a quick disclaimer which I gave before, but I'll just repeat it, that this is a crash course only. If you have not done anything, like you have not studied, and this is the first time you're reading about the CCSP, this video will not magically make you pass the examination. I've made this course for revision. It's for clearing up your concepts. It's always good to have a revision before the examination, but this should not be your only source of studying for the exam. You should look at the book. You should make your notes. You should practice papers and all that. Please do that and then look at it. It's always good to have a revision before the examination, but don't make this your only thing. Okay, and guys, if you please do like and subscribe to this channel. If you like this video, comment on it, like it, share it. So that will really help to reach the maximum amount of people. Thank you for that. Okay, so quick revision. Like we've already covered the first domain, which is cloud concepts, architecture, and design. We have over 6 security domains within the CCSP common body of knowledge. And we're going to be covering with today cloud data security. Okay, this one. Now, this is the most heavily weighted domain on the CCSP exam at 20%. And it covers, one of the most important topic, which is identifying, classifying, and securing cloud data. So it's going to cover everything, from the cloud data cycle, like what are the things you have to understand, how you have to secure that data, right up to the destruction. Each of the cloud models, infrastructure as a service, platform as a service, software as a service, they have their own data storage types, their own risks. So that's what domain 2 does. It basically defines these types, identifies what are the threats that are there, and what are the controls you have to put in place, okay? It covers basically designing and implementing a data security strategy that fits within what cloud model you're talking about. So let's get started, guys, with the first topic, which is the cloud security data lifecycle, the cloud secure data lifecycle. And this is very important because, they say security follows the data. So wherever your data is, your security should be following, and it should be there at all life cycles, okay? As a CCSP, you need to understand how data security changes throughout the various phases, okay? And so what are we talking about here? These are the one. This is the cloud data life cycle. What happens, data is created, right? This can be freshly generated content. Maybe you copy pasted, you imported data into the cloud, okay? Or it's existing data that has been created or modified, okay? So when you create data, this is the best time to put in your controls, right? You can put in your classifications, your data tags, according to how sensitive the data is, okay? And then move on to the store phase. Now, the storage phase, usually it happens right after the create phase. In this phase, the data that you created is going to get stored to some sort of digital storage, right? I don't know, some volume, some file storage. And this is how it gets stored. Then the next one is the use. Now, you've created it, you've stored it. Now, this is where the viewing or the processing and the consumption of data happens. That was previously created. And the use phase is where some of the greatest threats come to the data, So that's why you need to have all sorts of controls there: file access monitoring, logging and monitoring, data classification, information rights management. All these things need to be there, and we'll look at these in detail. Okay, the next one is the share. In the share one, basically the data that is now it's made available for other people like employees, customers, partners, and usually it travels through a lot of networks, public and private networks. You need to make sure that you have controls like encryption, like data loss prevention, DLP, all those things are there. Next term is the archive phase. What happens in archive? Archive is basically your data gets transitioned from active storage to long-term cold storage. You had data, maybe the data is 1 year old, 2 year old, you no longer need it. You don't need to put it into the live storage and get costs. You can transition it slowly to a low cost storage, okay? And usually it's called a cold storage, and it's like a less expensive version of storage. That's usually called archiving. It happens in on-prem also, right? You copy data into a backup tape and send it somewhere. And the last phase is destruction. This is the final phase of the data life cycle, and destroying data usually it's somewhat different in the cloud, as we're going to see. But at a high level, these are the different phases of data. Okay, and one thing we need to understand is data dispersion. What is data dispersion? Simply put, that your data gets replicated throughout multiple regions, cities, or even countries around the world. And data dispersion is a very like integral feature of cloud. Like clouds, all the cloud providers, they provide it, and that's how they do the redundancy. Your data is getting spread across all the regions. Okay, but you need to, of course, make sure that your cloud service provider, they understand that they can't just copy data to any region. That's why you need to look at your contracts and make sure it doesn't get copied to somewhere where you'll get a fine, right? So just as an example, if you look at Amazon, right? AWS, this is where I currently work. But if you look at how they've structured it, they have like around 87 availability zones across 27 geographic regions. Now that data can be copied. You can potentially copy data to any of these regions. So this is how the data gets dispersed. So even if your data center gets destroyed, the Amazon one, they still have data spread all across the regions. So this is what we talk about when we're talking about data dispersion. Okay, so now we're going to talk about the cloud data storage architecture. Now each of the cloud categories like IaaS, PaaS, SaaS, all of them, they have actually they have to store data, right? But each of the model, they use their own storage types, and each of the storage types, they have their own risks and security threats. So as you design and implement, right, you understand what sort of like model you're going to be using. You need to understand what are the risks there. As a CCSP, you need to understand, like for example, IaaS will use volume and object storage. PaaS will use structured and unstructured data, and SaaS can have like a wide variety of storage types. So let's start. First is infrastructure as a service. We've already discussed this. I'm not going to define, but basically, this is we're talking about infrastructure like computing power, networking, storage, which you get on the cloud. Okay. So how does it store data? Usually, so it uses volume storage or file storage. Now, volume, if you don't know, it's like a virtual hard drive that you attach to a server, like a virtual machine. It's very similar to a physical hard drive, right? And the operating system, the virtual machine operating system, it views the same as like you would view any physical hard drive. Okay, and it can be formatted and you can access it. All the cloud providers provide this. The second one was the object storage. Object storage, you can think of it like a folder in the cloud. The simplest example would be AWS S3. S3, if you've ever used, it's just like a folder in the cloud, and you can put stuff like files there, photos, videos, documents. Most of the cloud service providers, they have this. It's just like a Windows folder, and you can put data there. But talking about volume storage, and just as an example, this is what it looks like. If you've ever worked in Amazon, like within Amazon Web Services, when you create a server so this will give you this option, right? I'm provisioning a server in AWS. It's saying, okay, look, these are the volumes which you have available, which you can attach to that server. So this is how it looks like with infrastructure as a service. Okay, so moving on to the next one, which is platform as a service. Now we talked about platform as a service, right? So this is basically, it gives developers the freedom to like build their software without worrying about operating system, software updates, storage, all those things you don't need to worry about. You just need to provision an environment and you can get to work and start creating applications. How does PaaS store? So PaaS has two types. It is structured and unstructured. So just by the name, you can see structured data is data that is very highly organized, categorized, normalized, like database tables or Excel sheets. You can put this data into like a database or a relational database. Rows and columns we are talking about, right? Anytime you think about structured data, just think about rows and columns and you can understand, like you can run SQL queries on that. And unstructured data is basically data which you cannot just format into like a topical data structure, like a database. Usually we're talking about here audio files, video files, Word documents, web pages. Those are the sort of things which you need to be able to store and which PaaS needs to store, okay? So just to give an example, so this is how it looks like, structured data and unstructured data. Like I said, structured data it comes in a very organized format like Excel sheets or a database. Tables and columns are there. You have metadata. It's very easy to search this. And unstructured data, it can be text or binary data. It's much more like difficult to discover and search. And like sometimes you can get limitations. And usually people put labels or metadata on unstructured data, which enables them to find this. So this is the sort of data which you'll find in PaaS. Now moving on to the last one, which is software as a service. We've already discussed this. If you've used the internet, you've already used software as a service. It's the most common model. It's like anything you consume over, it's like an application which you consume over the internet, right? Like Dropbox, Salesforce, Gmail, all of them are SaaS. And you only need to access the application. You don't need to worry about anything. Okay. And so what are the things, how does it store? So usually the SaaS model, usually it utilizes two types of data storage. One is the information storage and management. This is basically you're entering data into the application, right? Into the web interface, and the application stores that data in a backend database, or data or you could have content and file storage. And here the customer is uploading data through the web application, but instead of in like a database, it's stored in other storage mechanisms which the users can access. So it's not like there's a lot of overlap sometimes between the models, but just try to understand it from a CCSP perspective. What are the different models and how they store data? And when we talk about threats to these data, so now we understood. So these are the threats we're talking about. So we have unauthorized access, data leakage, corruption of data, denial of service. As customer, when you're moving your IT infrastructure or sensitive data to the cloud, you need to understand these things, right? You need to have a strategy to like make sure that these all these risks are mitigated. Okay, when we're talking about these things like unauthorized access, somebody can get access to the data even if they, because they didn't have permissions, but they got permissions. Data leakage can happen, right? Data can get leaked out. Corruption of data can happen. Somebody can access it. Somebody can try to mess up. Ransomware can come in. And of course, you have denial of service, where somebody can actually bring this data down, delete it, and the customers are or the users, they are no longer able to access this data. So all these are the sort of threats which are there. So now we're going to be talking about data security technologies and strategies. So we've talked about the threats, right, at a high level. Now, what can you do to prevent it? Like, what are the controls you can put in to protect your data? So like I said, the next step is to consider how you can implement these data controls and how you can what this section is going to do is going to deep dive into several data security technologies. And you're not, as a CCSP, you're not just expected to know them, okay? But you need to understand how they work, what are the different technologies, what are the types of use, and what sort of data you're going to be using them. So you need to understand these technologies at a high level. What am I talking about? So we're talking about things like encryption, hashing, data loss prevention, DLP, masking and obfuscation, tokenization. So we're going to look at each of them in detail and try to understand. But like I said, this section is going to deep dive into all of them. And like you need to, like I said, don't fall into the trap. You just blindly implementing and tools one after the other. You need to have a proper strategy, what you're trying to protect. Okay. So first off is encryption. I think encryption, if you've ever done a little bit of security, it's one of the most basic or foundational security technologies, right? And what you have to do, and especially in the cloud, right? When cloud, you have things like multi-tenancy, where your data is being shared with other customers, right? On the same physical hardware, your data is there. So you need to make sure that the things like encryption are there, that even if something happens, your data will be secured. Okay. What is encryption? Just at a high level, encryption is basically three things which happen. The data which is there, it is in clear text. Then you run it through some sort of a algorithm, like a key management system, which will use a key to encrypt that data using an algorithm. And then you get ciphertext, right? So those are the things which are there. And the more important thing which you always have to keep and understand, that like the encryption keys, you need to secure them very, very carefully, because the entire security of encryption, it depends on those encryption keys. If those encryption keys are compromised, believe me, your whole encryption and key strategy is compromised. So what are the challenges which you might face? Like, there are a lot of things you need to understand, like encryption. Now you might say that we should encrypt everything, right? That is the ideal state. Everything is encrypted. Okay. I think the chief security officer of Amazon, he used to say that you should dance like nobody is watching, but you should encrypt like everybody is watching, which I thought was quite funny, because it's quite true also. But like I said, there is a performance impact from encryption also, right? When you encrypt stuff, there will be a performance impact. And so if you encrypt everything, then things will get slowed down. So you need to do a risk assessment and try to understand where you need to encrypt it. And what else is there? So almost all data processing, when you encrypt something, it will be in an unencrypted state. So you need to understand that at some point in time, data has to be unencrypted, right? And that is where you need to make sure the controls are there. Other thing is encryption keys are cached in memory when it's in use, and they stay there for some time. And you have to be very careful because in the cloud you have a multi-tenant environment, right? And memory is shared between the cloud service providers, the customers. The other thing is the cloud data gets replicated, right? Between one region to the other. A lot of times those keys are only in one region. So you might copy data out to another region, but you're not able to decrypt it because that decryption keys are not there. Other thing is the data keeps changing, right? Data changes from one state to another, and you need to make sure those controls are there in all the states. Other thing is data integrity. Now, encryption is great, but it's usually not used for integrity purposes. Then there are other tools like hashing. So you need to make sure you're not just using encryption because it's not just confidentiality. You need to think about things like data integrity also. What if somebody tries to change the data instead of just trying to access it? And lastly, which I mentioned before, which is very, very important, the effectiveness of encryption is completely dependent upon how securely you are treating the encryption keys. As soon as an encryption key gets into the wrong hands, all data that is protected with a key is compromised, okay? And keys that are managed by the cloud service provider, they can potentially get access by malicious people, right? So you need to make sure that that security is there. It doesn't matter whether you're doing encryption in the cloud or on-prem. You need to secure those encryption keys. So this is the life cycle of the key management. So when you're talking about securing keys, there are 4 phases, which is key generation, key distribution, key storage, and key destruction. Now, when you talk about the first one, key generation, you have to generate encrypted keys within this very secure environment. Usually we use HSMs. They are FIPS 142, the one we discussed in the domain 1. They usually validated by that standard Federal Information Processing Standard 140-2, and they have been tested and certified to meet certain requirements so that nobody can come in and tamper the keys or try to change them, okay? The second one is distribution. Okay, so you've created your key. Now it's important to distribute them, right? To make sure that nobody can steal them or compromise them. Usually the keys, they are encrypted with another key, and it's like a PKI, the public key infrastructure. So even if like somebody gets that, he won't be able to decrypt it, okay? The next one is key storage. So now you have the key, you've received the key, you have to store it. You have to make sure it's never stored clearly in plain text. And you can store them on a virtual machine. A lot of cloud providers, they give like a key management system in the cloud, or you can have an HSM. It's like a physical device where you store the keys. So all these options are there, but you need to like understand them. And lastly is key destruction or deletion. So at the end of encryption, like usually keys have a life cycle, like 3 years, 5 years, 1 year. It depends, right? And the key will no longer be needed. So the key destruction is basically you can remove that key and you can remove any information. Just make sure, guys, if you destroy that key and you haven't like decrypted that data with that key, then you can effectively like you'll never be able to get that data back. So you can actually do it like a denial of service upon yourself. I've seen it happen sometimes with people. What they do is they destroy the key, but then they find out they had actually some data which they did not decrypt. And now that data you cannot decrypt it because you don't have the key anymore. So actually you did like a sort of a denial of service. So it's very, you have to be very, very careful when like doing key destruction or deletion. Make sure you have a proper process to be followed. So that covers encryption. Next on, move on to the next one, which was hashing. So what is hashing? A lot of people sometimes they get confused between hashing and encryption. They think it's the same thing. It's not. Encryption basically encrypts the data, right? And it's reversible. What does hashing do? Hashing looks at the data and then it runs an algorithm. It generates a unique number, okay? And hashing you can apply to any data, documents, images, database files, virtual machines. But usually it's used for integrity. So hashes, it's like a fingerprint, right? And like if somebody changes that file, the hash will change, okay? And it's very, very useful when you want to make sure that nobody has tampered with data. Like you copy like some data from on-prem to the cloud and you want to make sure nobody has messed with this data, you can generate a hash, okay, when you're looking at the data on-prem, and when you send it to cloud, then you can run that hash again. If it's the same, then nobody has tampered with that data. So this is what we talk about hashing, and hashing is like one way, right? So like it's a one way, it's not like encryption that you can decrypt it. It's only because you cannot get the actual data back from that hash. So you need to understand encryption is two-way, hashing is one way. So this is just an example, like sometimes people like to hash credit cards, right? They don't want to store credit cards. Like, so you get a card, You run it through the hashing and you get the hash credit card. And this is just used for integrity, that nobody has messed with the credit card number. So just make sure you understand the difference between encryption and hashing. Okay, what else is there? Anonymization. So what is anonymization? If you have ever worked in like GDPR or privacy, so you can put things like encryption, but what if you need to use that data, right? So basically anonymization or data de-identification, it's the process of removing information that can be used to identify anybody from a data set. Like you have like a list of columns, you can remove any like data which uniquely identifies people. And usually this is used in privacy when you have things like PII or cardholder data, right? You need to make sure that nobody can look at that data and say, okay, this data belongs to like Tamur or somebody other guy, because there's nothing there to uniquely identify it. And there are two ways of doing it. One is masking and the other one is tokenization. Okay, so let's take a look at them. So masking is quite easy. I mean, if you worked with credit card numbers, you basically replace partially or completely the sensitive data with random characters, okay? Or you can just put one character over there. So usually this is the most popular form of data masking, which is used in credit card environments, right? You can first, apart from the first four, last six, you can remove first six, last four. You can just put XXXX0000 there. So this is how it basically, they can do it. You can do a number of ways, like there are things like substitution. You can just remove data there. You can jumble up data, you can scramble it, you can delete it, completely remove that data. So all those things are there. A lot of times people like, when they want to copy data from production to test environment, this is what they do. They mask that data or they obfuscate all the sensitive data. So even if it's there in UAT, nobody can mess with it. Okay, and the other one I was talking about, so yeah, and these are the two types of masking. One is static and one is dynamic. What is the difference? So static masking is the process of, duplicating the original data and you make a copy of it. Okay, and in the copy, all the sensitive data has been masked. So this is like I talked about, when you want to copy production data into a development environment, this is a type of masking you will be using. You create a copy and in the copy, all that data has been masked. And the other one is dynamic data masking. So this is like real time and you're not creating a separate copy here. This is on the fly happening. And the most common example is when you're like working in a call center and you need to see somebody's credit card number, right? So when the credit card number comes up, it's coming from the production system, but it gets masked on the screen. So this is basically a very common thing, or it's like a social security number or medical data. Those things get masked. So this is the first one. Now the other one, which was tokenization. What is tokenization? It's the process of you just take that sensitive data and you put another number with a completely non-sensitive number there called a token. So the token is just a reference back to that original data, but it has no meaning by itself. So supposing like you have a credit card number and you send it to a tokenization system or a service and you get a token, right? Now that token, even if an attacker gets a hold of that token, he can't do anything with it. There is a mapping between the token and the card number, but the attacker has no way of doing it because he would need access to the detokenization service. And like I said, this is again used in credit card environments quite a lot. They have things like tokenization as a service where you send a credit card number and you get a 16-digit token back. And that token you can store easily. And even if that token gets compromised, nobody can do anything with it because there's nothing there which you can refer back to the card number unless you have access to the detokenization service. So this is the second way of doing it. So just keep that in mind. You have masking and you have tokenization. So now moving on to the next chapter, guys. Now we're going to talking about data loss prevention. If you worked in security, I mean, this should be something which is very, very common to you. Most cybersecurity professionals are familiar with data loss prevention or data leakage prevention. It's the set of technologies you use to identify, classify sensitive data, and it doesn't get lost. So basically, you don't want that data leaving your environment or leaving your environment in an insecure state. So this is basically what it looks like. Yeah, like you have sensitive data and it's being sent, maybe it's through a website or an email or copied out to a USB. So what it does, it restricts it. So nobody unauthorized can get access to the data, right? And you properly use a DLP, it goes a long way to helping organizations protect their confidentiality, right? DLP basically analyzes the data. It identifies if there's anything sensitive in it, and it prevents users from copying it out, right? So when you're designing like a DLP strategy, you need to understand where this technology will fit in and you need to properly understand all the controls, and you make sure those policies are testing. You don't want to stop actual data from going out. And because data is, it can be a cloud, non-cloud, like if you don't implement it properly, what is going to happen is then the data leakage will happen, the data will get copied out, right? So you need to make sure all those things are being thought about. And when you implement a DLP, so there are basically three core components or three stages. One is discovery. In the first stage of DLP, you discover or classify your data, right? You're finding out all the instances of data, and and you're classifying it so that know what type of data is there. And the next one is monitoring. So once you've found out all the data and you've classified it, now you can monitor it, right? So this is how the DLP will be working. It will find out where the data is going, and you're monitoring it to make sure that no policy violations happen. And the last stage, the final DLP stage, is enforcement. Enforcement is where the action is taken, where you define policy and say, okay, if somebody tries to email out or copy out credit card data, block it. Okay. And these actions are configured based on the classification of the data. You need to understand what sort of data is sensitive. And if it's less sensitive, you don't have to block it. You can maybe log it or alert it, right? Usually the most common case I've seen is banks or financial services. They want to detect credit card numbers being emailed to unauthorized domains, and they want to stop the email in the track, right, before it even leaves the corporate network. Okay, so what are the DLP data states? Now, like I mentioned before, security follows the data, right? And DLP is no different. So when you're creating a DLP implementation strategy, it's important that you consider the techniques for monitoring the activity or all the data states. So for DLP, you have DLP at rest, right? So basically the DLP implementation is stored wherever the data is stored, like a workstation or a file server or some sort of a other sort of like a storage system, right? This is usually the simplest of the type of data which is there. The second one is DLP in transit. So this is network-based DLP, and it involves monitoring outbound data, right? Email, HTTPS, SSH, all those sort of things, they have to be monitored, email. And last one is DLP in use. This is real time. So this is host-based or endpoint-based. Like this is an agent which you install like on the workstation or other endpoint device, and you're basically monitoring all the data on the device. And then because it gives you much more insight than DLP in transit can give you, or the network-based DLP. So you understand, because of the massive scale of so many cloud environments, DLP can be a big challenge. So you can't always put it like an agent on all the cloud environments. So you need to make sure that you have all three of these are you looking at. You are looking at DLP at rest, network DLP, and the host-based DLP. So you have a mix and match of these things so you can have a proper implemented DLP strategy. So now that you've understood like things which you have to keep in mind, right? Now that you understood how DLP can be used to protect your data, so what are the things you need to keep in mind? Like I said, cloud data is highly distributed, right? It's replicated across locations. Data can move between servers, from one data center to another, from backup storage, from a customer to a cloud provider. So DLP has to be there at all stages. And DLP technologies can impact performance also, especially host-based DLP, because it's scanning all the data that is there, right? All the file. If you have like gigabytes of data, DLP will start scanning it. It can have a performance impact. And then lastly, cloud-based DLPs, especially, they can get very expensive. The pay for the metered service or pay for what you use model, it's a great saving when it comes to customers. But when it comes to DLP, the constant utilization of the traffic and usage of the traffic, it can quickly become very, very expensive. So you need to make sure what sort of model you're going to be using. Okay, so I hope this made you understand DLP in a better light and what are the things which the CCSP will be focusing on. Okay, next step is what? Data discovery. So before you can protect your sensitive data, first you need to locate it, right? Data discovery, like the name says, it's a process of finding and identifying sensitive information in environment. It's a very, very important step, because honestly, you cannot secure something if you don't know where it's stored, right? Where it exists. So, and data discovery is also like sometimes you need it for regulatory compliance, like things like PCI, GDPR. You need to know where you're storing that sensitive data, because that is a requirement of the standard. So what are the approaches for data discovery? Like how do you find this data? And because data is so dynamic, so many data is being changing and created. So there are multiple ways. Okay. First would be metadata. Metadata, if you don't know, it's data about data. It can be file names, file headers, other information that provides insight about the data and its contents. So you can actually analyze that metadata and you can find out to locate sensitive data. Second one is labeling. Remember what we talked about data being created. When data is being created, you can actually put a label there like sensitive or confidential, and then the data discovery will find this sort of files. And the lastly and the most common one is content. The content is you actually look inside the file. So that discovery software is going to look inside the file and say, oh, okay, there are credit card numbers here, there are social security numbers there, there's GDPR data there, and then it's going to discover that data and let you know. Okay, so I hope you understand. So there's metadata, there are labels, and there are content. And if you remember, please don't forget structured data and unstructured data, like I told you. So we have things like when it's doing the data discovery, it's going to be looking at both of these type of data, right? And what is structured data? It's like databases, rows, columns, structured in a proper way, right? And unstructured data is there is no proper structure there. It can be audio files, video files, images, all those sort of things are there. But the important thing is you need to discover both of these data. Both of those data needs to be discovered. So now that you've done the discovery, what else is the next phase? So the let's take a look here. Data classification. So you've already done it, right? I mean, you've already found the data. Now, data classification is the process of categorizing and organizing data based on the level of sensitivity. So you need to like classify that data. It's the next step to data discovery. You found the data. Now you need to classify it, right? Based on what the data was found. If it's credit card data, it can be very sensitive. If it's GDPR data, if it's just, I don't know, like people's age or something like that, something less sensitive, it can be a lesser sensitivity, but you need to classify it. So, and if you remember what we discussed earlier, it's the same thing. When you do for data classification, you can look at the metadata, right? And the metadata can tell you what sort of data is there, and you can classify, give it a label based on that. Or the label itself of the file. The file can have a label of something like at the time it was created, and then you can classify it based on that. Or like I said, the last one is looking inside the data. So if you have sensitive data, it will look inside it, and based on the data discovery that was done, it will put a label there that this is a confidential data. And when we talk about sensitive data, we have like there are many types of sensitive data, but the most common one is personal health information. You know, like this is in the medical field, or we have personally identifiable information. You must have heard of PII if you've ever worked in privacy, and all sorts of other things are there. And the last one is the cardholder data. Cardholder data is basically the credit card numbers which are there, and all those other things. Like if you ever worked in the credit card industry, those are the sort of things which you have to be understanding. So these are the three types of data which is there and which you have to keep in mind. So one is personal health information, one is personal identifier information, cardholder data. Those are the three types of things which you have to look at, and these fall under the sensitive type of data. Okay, and so now we've done the data classification. So what can we do now? So okay, we classified it, big deal. What can we do now? So this is where we move on to the next phase, which is information rights management. This is a technology that is you used based on what you did before, like you discovered data and you classified it. Now you can use a type of technology to protect that data, like files, even emails, webmail, all those sort of things. And what you can do is based on how the data is, you can put controls which can limit who can view, copy, forward, delete that data. And this is how it all comes together, right? Based on the data classification and data discovery. So what are we talking about here? IRM, or information rights management. It gives you like amazing control over that data. So you can control, like I said, who can edit, copy, print, download. And the best thing is the controls are following that data. So even if that file, it gets copied out, you email it, it will still have those controls, right? And it works in tandem with data classification. So these are the sort of things which are there, and you use it to get classified, and all those sorts of things are there. So the best thing about, like I said, information rights management is it will follow the data wherever the data is, and then you can really put fine-grained controls based on that. So what are the features of this? So many, like these are the things which are there. Like one is continuous protection. Like I said, that controls will be attached with that document, right? So wherever that document is, whether it's inside your environment or outside, You can block who can copy, paste, all those sort of things are there. And you can do automatic expiration also. So supposing you've sent this data out to someone and you can actually mark it to so that it gets deleted after 1 month. You can put those controls. And it has dynamic control, like I said, right? So those controls which it dynamically kicking in, maybe that file is being viewed, somebody tries to print it, it'll kick in right there. And auditability, you can actually look at where the data is going, who is tampering with it, who is looking at it, and it integrates with the other solutions also, like email, what do you call your office sort of tools, all your word processing tools like Word and Office. So all those features have to be there with a proper IRAM solution. So I hope you understood, guys, what are the benefits of the information rights management and how it links with all your other tools also. Okay, and data retention, deletion, and archiving. So we're moving on to the last bit of phases, like when it comes to data. So like I said, that if you have a proper data strategy, it should address risk at every stage of the data life cycle, right? So these concepts are very important when it comes to cloud computing, especially when it comes to making sure you're meeting regulatory requirements, guys. So what is data retention is basically how long can we hold on to information, right? And you might have in the banking sector, they might have for 5 years. And what do you call it? It's based on the regulatory requirements also. And one important thing you need to understand is incident response. So if something happens, if your organization gets compromised, that activity can potentially, you can not know about it for weeks, months, or maybe even years, worst case scenario, right? So your data retention policy need to look at that. So you don't want to delete data and later find out you don't have access to it, right? And you need to think about a lot of things like the cost. Like if you have data which is 1 year old, do you still need that in the active storage? Maybe you can move it to a low cost archive, right, in the cloud. And what sort of format you need in, what sort of storage needs to be there, all those sort of things you need to look at based like a holistic approach to data retention. So you need to make sure how quickly can I access it, what's the cost of keeping it there, what's the format I want to store it. All those things are there. You need to understand. And when you talk about data retention, the other word would be data deletion. And it's a very critical and sometimes overlooked component of data protection. Like you can delete data when you no longer need it, right? And when you don't have effective data deletion, it can sometimes lead to data leakage because you're keeping unnecessary data which is no longer needed, right? Yeah, so you need to think about those things. So we have things like in the cloud. Of course, in the cloud, you cannot physically destroy stuff, right? But you might have requirements to remove that data. So you have many techniques which are present in the cloud for securely removing that data. And let's take a look at it. So what are there? One is overwriting. You have something like encryption or crypto shredding and degaussing and physical destruction. So when you talk about overwriting is just you overwrite random data over the actual data 1 or 2 times. Multiple passes of overwriting. It gives you assurance that nobody can look at that data again. Sometimes people do data encryption. You might be thinking, why is encryption being looked at it for deletion? Well, what you can do is you can use encryption to make the data unreadable. What you do is you encrypt it and without the encryption key. So basically, it's in a way you're deleting that data, right? You're deleting that key. It's called crypto shredding. So basically, it's called crypto shredding. So nobody can get access to the data now because nobody has that key anymore, right? Other one is degaussing. Degaussing, if you know, it's a data erasure method. It uses a magnetic field to destroy data on magnetic media, like hard drives. This is quite effective, but you can't really do it on cloud environments, right? And the last one is physical destruction. So after everything fails, physical destruction gets the job done. And you can simply take a hammer, or you have vendors there which completely destroy the data. They burn it, pulverize it, and do the other stuff. But obviously you can't do it in the cloud, right? Because your hardware is being shared by other customers also. So it's not like a practical solution for the cloud. Data archiving. So we talked about data archiving, right? It's the process of removing your data from a production system and transferring it to the other longer term storage systems. And by this, you can actually cut down your cost, and you can, because you're sending less important data to cheaper storage options, and you use it to use your production resources for more important data. Basically, this is data which you no longer need for day-to-day use, but you still need to keep it, but you don't need to keep it as part of a production system. And cloud providers, they give you lots of options. What are the things you need to keep in mind? What do you have to consider? The format, right? When you archive the data, you need to pay special attention to the format of the data. and what type of, because technology keeps changing and you might find out you're not even able to restore that data. Business continuity and disaster recovery. You need to make sure your data archiving is aligned with your business continuity and disaster recovery plans. Monitoring and testing. This is very important because as part of the archiving, you need to make sure that the data can be properly monitored and recovered, right? And you need to test that data is usable. And lastly, protecting. So even if you're putting it in long-term storage, you need to make sure that data is classified and the controls are there, right? Encryption, classification, all those controls are there. And lastly, restoring. So when we talk about restoring, you need to test it and make sure that there might be some data that might never need to be restored, or there will be data that you do need to restore. You need to test it out and make sure that that data is accessible when you need it. So yeah, data retention. Now, when we talk about data retention, it's a very, very simple thing. How long can we store that data? So basically, if you're a bank, you might have a requirement you can store customer data for 5 years only, right? And after that, you might no longer be allowed to. So you need to have those sort of regulations defined, usually with your legal department. You need to think about things like cost, format, storage, and regulatory requirements. And one very important thing is incident response. So with incident response, because you might have an incident which might go undetected for months and even years. And if you you might need to keep that data in archive, because if an incident happens, you need to go back and look at that data, right? So organizations may opt to retain data for longer periods. And you need to make sure that you're not violating any regulatory compliance. So ultimately, the length of time that you retain data, it depends on the classification, what sort of format is there, what sort of storage is there. So this is something you need to discuss with your other teams like legal and everyone before you move ahead. Legal hold. So what is legal hold, guys? Legal hold is the process of preserving any data that you might need during a legal investigation. A legal hold, it basically gets initiated when you get like a legal legal order from like a judge or a court that there's a legal proceedings going on and this data has to be preserved, and how it must be preserved and secured. And usually it lasts until those legal proceedings are finished. And this links back to, if you're familiar with the concept of e-discovery. So basically, when you're working in forensics, right, you need to make sure that when an incident happens, that data is secured. You're putting it into a secure image. Nobody can tamper with that data. Nobody can go and change that data. So this is something as a CCSP candidate you should be familiar with. And an organization, if you get like a legal hold, you must be prepared to archive and store and protect that data as per the requirements which are sent out in that legal notice. So you need to make sure that when you're evaluating a cloud provider, you think about these things when you're negotiating your cloud contracts and your SLAs. Okay, now we're moving on to the end, guys. Now let's talk about auditability, traceability, and accountability of data events. Wow, that's a long thing to say. Basically, now you understood the various stages through which the data moves in the cloud environments, right? And how you protect it. So, but you need to make sure that how do you find out, like, what are the events which are happening? What are the things you need to be able to look at to find out what happened at what stage? So this section is going to outline some of the key event sources available for IaaS, PaaS, and SaaS cloud customers. So in SaaS cloud environments, this is quite easy because the cloud service provider, he is responsible for the entire infrastructure, right? As well as the application. But the thing might be you might have less logs available as opposed to the other ones. So what do you need to do? You can look at things like, admin logs, user account logs, application logs, web server logs, database logs. All these things you need to understand. And very important, you need to understand the shared responsibility model, guys, which I told you. Because if you understand then you will understand what sort of things you will have available from the SaaS provider. Next one is platform as a service. So with platform as a service, you have more access to data, right? Because along with the application, you have access to the development environment also. So then you need to think about things like where you can get data from, input, output validations, authentication, authorization failures, like session failures, application errors, application startup shutdowns, provisional escalations, source code modifications, changes in the data. All these things you'll get events from them. And lastly is infrastructure as a service. With IaaS, you have the greatest access to logs, right? In an IaaS cloud environment, you have access over the entire environment. and mostly almost all the infrastructure events and logs are available. But to prevent any surprises, you should be make sure that you have access to those logs, and those are captured in the SLA. Okay, so we have things like network logs, hypervisor logs, DNS server logs, management console, VM, API, billing. I mean, you name it, all those things are there. But now that you have the logs, like, one thing very important, you need to make sure that you're capturing the right data within the logs, right? The basic question you need to ask yourself is who, what, where, and when. These are the things you need to know. So when is who, like it can be an IP address or username. What was the type of event, the severity, the description. Where, like, can be a location, maybe a referrer, maybe it was a script, and when. Okay, and that is the date and time. So these are all the things you need to take into mind when you want to make sure that you are able to relate things back to that user, and what not to capture. So it's very easy to capture stuff, but you need to remember there are some things which you don't need to capture, right? And these are the things like source code. You don't need source code within the logs. Access tokens, absolutely not. PII, PHI, no, absolute no. Passwords, keys, anything which the user is not consented to. These are the things you absolutely do not want to be accidentally capturing. Okay, so now logging, storing, and analyzing data. And now that you understood what has to be captured, what are things that not to be captured, now you can look at the process of actually logging, storing, and analyzing those data events. And there are several phases of this. First step would be the collection one, right? You need to make sure that you have to collect all those logs. And what are the things you need to keep in mind? First one is validation. You need to make sure that the correct logs are being there, and like no issues are happening, right? And sanitization, you don't want to capture data which you're not required to capture, right? And even from a security perspective, there can be things like injection attacks happening on log injection, and they can actually mess up your logs. An attacker can create false log entries or malicious content within the logs. So you need to validate those logs also. Okay, encoding, you make sure that the data is captured in the correct log format. And injection attacks, if you are writing to databases, make sure that you filter it for SQL injection attacks, right? Data leakage. And data leakage, like data can get leaked out. You can accidentally capture sensitive data. And of course, time synchronization. When you're capturing logging from all the other stuff, you need to make sure that all that data is captured, right? And the time is synchronized, because if you have logs at different timestamps, you will not be able to do correlation. So verification, now that you've captured it, logging, what are the things you need to periodically test when you're thinking about logging? Well, the first step would be that the logging is working, right? I mean, the data is being captured as was expected, right? And injection attacks, I've already talked about. Failure testing. What's failure testing? Failure testing is you want to check, okay, what happens if a server stops sending logs, or if it's not able to send logs? What happens? Basically, you're simulating a loss of connectivity. And you need to have proper access controls over that log, right? Not everybody should be able to access it. If you're the security team, only the security team should have access to it. And lastly, misuse of logs, right? People can gain access to the logs, and they can actually start tampering with it, or they can actually get sensitive data from those logs. So all those things you need to keep into account. And what's the last thing? It is storage and analysis. So cloud environments produce a lot of data, right? And that data is useless if nobody is analyzing that data. So we have things like a security and information event management solution, SIEM. If you've ever worked, it's a log analysis situation, right? What does it do? It has multiple features. One thing it does is aggregation. So it takes all that data and combines it into one central location. It can do correlation. So it can take data from multiple sources and correlate it. So Tamu logged in here. He did this. He spun up a server. He did this. From different applications, it can correlate and tell you. It can do alerting. So you can create alerts to let you know if something is malicious is happening. And you can get dashboards. So if the CISO wants to know what are the key security events happening, you can look at that. And lastly, it's very, very useful in forensic analysis. So if there's an event, an SIEM can help you to reconstruct that event based on the log data that is there. Okay, guys, we've hit the last chapter, the last slide, and that is chain of custody. So chain of custody is basically very simple, guys. It is like it's the process of maintaining and documenting the sequence in which the events came, you got physical or electronic evidence from the time it's created till the time it's finally like presented in court. And electronic chain of custody, usually this is talked about the data life cycle, the data possession, location, chain, everything has to be captured. It's very, very important for legal and law enforcement, because if you're not able to prove chain of custody, you cannot use that as evidence during forensics and incident response. So very, very important topic. And lastly, non-repudiation. So the non-repudiation, what is that? It is simply that you cannot deny that you did this action. So non-repudiation, we discuss about things like hashing or digital signatures, right? Like if I do an event, I can't later on say, okay, I never did this. You have no way of proving it. No, we have things like hashing. We have things like digital signatures, which you can capture and use it to prove that, no, this person actually did carry out this data and this action, which is there. So, wow. So again, guys, I try to finish it before 1 hour, but this is turning into a full course. Yeah, but like I said, because this domain is very important and it accounts for over 20% of the CCSP. So like I said, let me know if you felt I should have covered other stuff. And if you like this video, do comment on it. Do subscribe to this channel if you haven't already. Thank you guys, and I'll see you in domain 3. Thank you very much.